Welcome to this course on Oracle Data Integrator Essentials. My name is Andreas Nobman, and I will be your guide through this screencast. In this first section, the ODI core concepts, we are going to take a look at the ODI key concepts, ETL and ELT and how ODI supports that. We will explore the graphical user interface, the ODI Studio. You will see the basics of topology, data models, reverse engineering. You will learn about the technologies and features supported by ODI. You will see the knowledge modules and how they define its strategy. And you will, last but not least, learn about the ODI staging area, the data flows, and the different flow parts. Let's start with the ODI key concepts. ODI is a declarative data integration tool, compared to Oracle Warehouse Builder, which follows procedural development methods. In this case, declarative means that you define your strategy and then can apply it to your data structure. This course of action has a lot of advantages and is state-of-the-art in application development. The aforementioned strategies are defined in ODI in so-called knowledge modules. You can customize them to your needs and enhance them with your data warehouse know-how. Out of the box, there are a lot of knowledge modules coming with the ODI for various technologies and methods. ODI strongly defines itself by what data is transformed, where the data is transformed, and how the data is transformed. So, how does it work in ODI? For this, let me first illustrate the data flow. ODI assumes the concept of a logical flow, which means the set of source rows equals the input of the flow, and the output of the flow is a set of actions that are performed against the target data set. We'll now look into developing with logical objects. In ODI, you always develop on logical objects. Logical objects are abstracted from real physical objects, but at the same time removing the complexity of your source data. This all to make your development easier. In ODI at design time, all objects are only referenced. That means, as long as you have not deployed an ODI object, all referenced objects within this development object are pointers to the embedded objects. This method makes it easier and less effort-intensive to carry out changes to strategy. You can develop once and then can apply your strategies, the knowledge modules. Most important to understand in this section is a strong separation between the how, the what, and the where. How data is transformed, the strategy, what data is transformed, and where it is transformed. And keep in mind that you are developing on logical objects, reducing the complexity of the often very heterogeneous physical environments of your landscape. And here is a slide with some references where you can find additional materials on ODI. In the next chapter, you'll learn the differences between extract load transform and extract transform load, and how they are both supported in ODI. As we are in the basic chapters within this section, you learn now the differences between ETL and ELT and how the both of them are supported in ODI. What is ETL? The abbreviation stands for Extract Transform Load and describes a typical process within data warehouse environments. Extracting data from sources, transforming it, and then finally loading it into some target data source. In ODI you can reproduce ETL in a simple interface. More details on this you'll see later. What's ELT then? Basically, it describes the same but in a different order of sequence. ELT, as the name already says, is extract, load, and transform. ELT is processed always directly in a database. The interpreter is missing. There is no interacting between source and target taken over by some separate instance. ODI, in fact, can be used for both methods. When doing ETL for ODI, this is the interpreter way, meaning that ODI acts as a transformation engine, processing actions on all rows of a dataset. The opposite is ELT, where ODI acts only as a generator, in fact, only generating the service requests the involved data service should execute. As a wrap-up, in ETL, the ODI, in fact the ODI agent, does all the transformation work. When doing ELT, the database is doing all the work. In my opinion, the latter is how it should be. The database is powerful, so it should do the work. In the next chapter, you'll get in touch with the ODI user interface, the ODI Studio. In the end, we work with data, so what you'll see is how you define the topologies and the data models. Within this chapter, you'll get some insight into the graphical user interface, the ODI Studio. Main focus is that you know where to look for the various components. So, what is ODI Studio? It serves to you as the main interface for all ODI activities. You can define the structures of your data here, the metadata, but also do all the development. And in the end, you can do all the operator tasks here, like reviewing execution logs and so on and so forth. To start ODI Studio, double-click on the ODI Studio symbol on your desktop, and you'll be led to this screen. So here the question pops up, what's necessary for you to log in to ODI Studio? First thing you do if you're in ODI Studio is you connect to the repository. So you click on that. Then, as we can see here, when clicking on this pencil, these are all the necessary and relevant information you have to enter before you can log into the ODI Studio. ODI Studio always needs a repository connection, and this is basically defined here in this connection information. First of all, you'll need an ODI user. Next, you need a user and a password to connect with that master repository. And last but not least, you'll need the name of the work repository you want to do your development in. A lot of information. Good is that you can really save it as a repository connection information. So what you see here is the connection is using the JDBC driver, and you see here the host name, the port, and the Oracle database SID. And here is the work repository. So we click on OK, and we click on Connect. The ODI Studio is divided into 4 sections: the Designer tab, the Operator tab, the Topology tab, and the Security tab. In the Designer, all development is taking place. You're creating projects, interfaces, packages, procedures, sequences, everything. Also, the data model and your knowledge modules can be found in this tab, though they are in a separate accordion. In the Operator tab, you'll find everything related to execution. Also, load plans, scheduling, and all-around deployment has its home base in this tab. In the Topology tab, you define your data server and the corresponding database schemas, the namespaces. And obviously, you have the contexts here, as you're developing only on logical objects in ODI, and the context is translating your logical topology to the physical topology. More details about that later. Also here you can define the functionality of your technology, your repositories, and the syntax of languages used in ODI. In the Security tab, you can create profiles, equals roles, and can assign users to them. One tip here, it's also possible to use external authentication directories like LDAP or Microsoft Active Directory for this. When going back to the Designer, you see that in a lot of accordions on the right edge of the top bar, you'll have some additional features. Import, export, edit release tag, all that. This is context sensitive, and you can use it everywhere. Just know that these import and export here, you can always do an export and back up your data, your work. This is making your life as an ODI developer much easier. Another useful tip, if you are in the topology, you can always click on Hide Unused Technologies so that you don't have all the technologies which are existing in ODI. ODI Studio is based on the JDeveloper GUI, so there are many windows. If you're working with it, some of them will disappear sometimes. From the View menu, you can get all of them back. You see all of them here, and you can activate them or deactivate them. Good news for frequent shortcut users. Ctrl-Z for copy and Ctrl-V for paste are running out of the box. You now saw some of the basics of ODI Studio. Next are the basics of ODI, how you define your topology, and all that. This is an important chapter as you learn how to define your topologies, reverse engineer metadata, and model your data models. Just one tip. Before you start with your work, take an empty piece of paper and draw out a matrix with all the data servers you want to use in your data integration projects. This makes it easier to do that work. You might ask yourself, what is the topology in ODI? Basically, it is your architecture, but separated into a physical and a logical one. The physical one is the real world, means the physical boxes. The logical one is an abstraction of the physical architecture, grouping it based on some purpose, some intent, and, of course, grouping by the functionality. of the underlying technology. The piece to connect both worlds, the physical and the logical one, is the context. Before we start with this, let me shortly list up the general way of proceeding in ODI. First, you define the topology, the physical and the logical architecture, means the backbone of your data. Then you're adding the data schemas and the work schemas. Afterwards, you create your data models based on those schemas. Then you reverse engineer your data structures into your data models. For example, the tables, the columns, the constraints, the indexes, and so on, the data types. And then finally, you can really start developing your data transformation tasks in interfaces, packages, and procedures. Now, as an example, let's assume we have the following physical landscape. We have two sites, one site containing development data, the other one containing test data. Spread over both of them are four different sources: data warehouse data, purchasing data, accounting data, and sales data. Data warehouse and purchase data are stored on the Microsoft SQL Server, while sales data and accounting data is partly stored on an Oracle database. Only for the data warehouse we have data on the development side. For all others, we only have data on our test site. You see here the physical landscape. How do you think does a logical landscape look, and what will be the context? The logical landscape looks exactly the same, and the contexts are development and test, making it possible to develop on the logical objects, while at the same time having the possibility to execute the transformations on two environments by simply switching the context, as you can see in this illustration. Let's take a look at that in ODI Studio. In the Topology tab, you can see that all technologies ODI can use are defined here. Of course, you can add technologies yourself. Important to understand, though, is that the technology defines the functionality of the underlying data servers. What you do under the technology is you define the physical data servers. I show that here for the Oracle technology. In fact, you define the JDBC or JNDI connection to your server, and the user and password credentials are used for that. Here is user, password, instance name, and if you change to the JDBC tab, you can enter here your JDBC URL, which is containing the hostname, the port, and the SID, the Oracle database SID. After testing this connection, you're done with the physical data server. Next you have to do is you have to add the containers holding the data. The namespaces, they are called in ODI. You have two of them. One where real data is stored, and a second one where the temporary objects are saved. In this case, I have a data warehouse load user who's doing all my load tasks, and this database schema I'm using as a temporary data store. We are now done with the physical topology, but in order to be able to work with logical objects, we of course have to define them, so we are changing to the logical architecture. And as you can see here, we have exactly the same architecture. Last but not least, we have to connect the two worlds, so we have to define our contexts. So we are clicking on Development Context. We are changing to the Schemas tab. And here you can assign, you can interconnect the logical schema with the physical schema. So contexts are used in order to be able to develop on logical objects, but being able to execute data transformations on various different physical environments by simply changing it. Once done with the topology, next step is to somehow get the structure of the data you want to transform. For this, we reverse engineer it to our data model. The data models are the containers for the data we want to work with. This means we'll have to take care that source and target data servers are defined here. In order to avoid that we as developer need to do that again, we are using the method of reverse engineering. Reverse engineering describes the process of retrieving the metadata directly from your data structures. In most of the cases, these data structures are saved in the database dictionary. As we work now project related, we have to change to the Designer tab. In the Designer tab, we open up the model accordion. We right-click and create a folder and data model as already prepared here. We give it a name, select a code and a technology, and we assign a logical schema. Then we change to the Reverse Engineering tab. Here we can decide which objects we want to reverse engineer from our database dictionary. After you have reverse engineered your data, the data model then contains the objects you reverse engineered, including all columns, constraints, indexes, and so on. What you can always do is you can do selective reverse engineering. If you click here on this third tab and click on New Data Stores and check all that boxes, you get a list of all objects which are existing in this specific data server. I just want to show you how the data is reverse engineered. So you see here one table with the name C customer. It has columns, cost ID, name and status. There is no filter applied, and we have a primary key constraint defined on that table. If you click on the customer ID column, you'll see how long this column is, what precision it has, and obviously what data type it is. All this can be tracked down in the data model. Of course, you can enhance your data model if you want to. You can add new columns and so on. You now saw how you define your source and target data servers and how you can build the data structures by reverse engineering. Next chapter is a basic explanation of the strategy development within the knowledge modules. As the name already says, it's all about defining your strategy. As you know, ODI is a declarative tool. So you declare your strategy once into the knowledge modules so that you can afterwards apply it to the other ODI vehicles. What is a knowledge module then? In fact, it is a code template defining the implementation pattern for a strategy you want to apply on your data. A strategy could, for example, be insert, update, or merge. Knowledge modules are generic pieces of code. Hence, they should reflect the shape of the data flow defined and, of course, the mapping residing in the ODI vehicle. To have generic code templates within knowledge modules, ODI substitution methods are used. Mappings in ODI are the expressions to be transformed. In ODI Studio, you can find the knowledge modules in the Designer tab. There are two scopes of knowledge modules. The project knowledge modules you can find in the projects, or the global knowledge modules, which you can find under global objects. As the name already indicates, global knowledge modules are valid for all projects, while project knowledge modules are only valid in exactly that one project where they have been defined. Beside of the scope, there are various types of knowledge modules. Integration knowledge modules, loading knowledge modules, reverse engineering knowledge modules, check knowledge modules responsible for the data quality, generalization knowledge modules, and service knowledge modules. In ODI, you can import already existing knowledge modules from your ODI installation. For this, right-click on Knowledge Modules, select Import Knowledge Modules. The basic folder containing all knowledge modules is Fusion Middleware Home /Oracle_ODI/XML-reference. I already imported one knowledge module, which is called IKM SQL Control Append. Please note that not all knowledge modules can be used for all pairs of technologies. Some are limited to a specific set of technologies. As you can see here, you can define the set, the pair of technologies here. If you select here a specific technology, then this knowledge module can only be used for this technology. Be aware that most of the knowledge modules are using the ODI staging area to store temporary data. For example, if the strategy is to detect changed data, as is the case in the slowly changing dimension knowledge modules, then the detection of the changes is happening using temporary tables. Summary of this chapter: in ODI, you define your data transformation methods in knowledge modules. More details about developing your own knowledge modules will come in a later section. Next is about the ODI staging area, data flows, and flow parts. The ODI staging area is the namespace where the temporary objects are stored. As you can influence the behavior of your data transformation by this, it is mandatory to know how to configure it. So where do I define the ODI staging area in ODI? The main object in ODI to develop data transformations are interfaces. You're not familiar with them yet, but I'll come to them later in detail. For now, I open one interface to demonstrate where the ODI staging area is configured. I mentioned it earlier. ODI assumes a logical flow, the path taken by data from the sources to the targets. The flow determines where and how data will be extracted, transformed, and integrated. To have the complete picture, the knowledge module are the code templates to translate the flow into source code. Back to the ODI staging area. General rule is, when sources and targets reside on the same data server, it's a single server flow. If one of them is stored on another server, a cross-server flow is created. By changing the location of the ODI staging area, you can select the flow type to be formed. Cross-server flows can also be artificially created by using a different data server than the target data server. This is reached by checking the checkbox in the definition tab of an interface. As we now have already opened an interface, let's go to the tab Flow. What you can see here in this picture is the data flow as ODI shows it. On the outermost right part of the flow is the integration flow part. Only one integration flow part exists per interface. On the left-hand side we have the extract and load part, of which can exist multiple instances, as we could have different data sources. There is another setting which has influence on the flow, the execution location, but this will be covered later. I will illustrate now the three different possibilities you have where to define the ODI staging area. The default one is to have the ODI staging area defined on your target data server. In your interface, it looks like this then. You have this checkbox unchecked, and your flow picture looks like that. All the sources, which are loaded using a load knowledge module, which are then joined here into our target and finally integrated using the IKM, the integration knowledge module, into our target data store. The next possibility you have is to define the ODI staging area on your source data server. For this you have to check this checkbox and you have to select the data server you want to use as ODI staging area. The flow picture looks like that here. You have only your source and your one source, which is a flat file here, and then you have the ODI staging area on the second source, where all the joins are happening, and there's one integration flow part here at the end of the flow, where the data is loaded finally in our target data server. Third and last option you have is to define the ODI staging area on another data server, a third data server. In this case, this is reached by using the in-memory engine. And the flow picture looks like that then. You have the sources, the flat file and the SQL Server files, which are joined in the memory engine and finally then integrated into your Oracle data warehouse. It is essential to understand the concept of ODI assuming a flow. You need to know that you can influence where the transformations are executed by setting the ODI staging area. In the next section, you'll get first hands-on time in the ODI Studio, taking a tour how to organize your projects and how to develop, finally, interfaces. In section 2 of this Oracle Data Integrator Essentials course, it's all about developing an ODI. In this section, we're going to take a look at how you organize your projects, what are mappings, how to create an interface, joins, datasets, filters and sequences, and temporary interfaces and lookups. This chapter will shortly introduce you to the possibilities to structure your ODI project. We are at the starting point of our project and ask ourselves how we can organize it the reasonable way. I don't say the described here is the best way, as the best way really depends on your specific project, but at least it's a start. What is a project in ODI? Basically, you find all the projects in ODI in your Designer tab. A project can contain the following objects: packages, procedures, interfaces, sequences, variables, user functions, knowledge modules, and last but not least, markers. So, you see a lot of things. In fact, a project reflects a functional domain or an integration project. Good question now is, when do I need a project and when a new folder? A project makes sense if you start a new integration object, but also if you want to have objects separated, e.g. for some new data warehouse activities. A folder is useful to organize everything and to define specific user privileges. Nevertheless, what I would always recommend when developing an ODI is to lean back, take a piece of paper, think, and write down what you want. This makes really everything easier. In ODI Studio in Designer tab, create a project. You do that by clicking here, selecting New Project, and saying My Project. Pay attention for the code here, as this is the reference you're using later, for example, for project variables. So in this case, I would say New as project code. If you follow the general approach to load a data warehouse, then I would create folders in your project following your data warehouse architecture. Like I did here in this example. I have 10 to load tables from source to stage, 20 from stage to glance, and so on. So give them names with a number in the beginning, otherwise they won't be sorted, that's a tip. And leave some space between the numbers. So not 1, 2, 3, but 10, 20, or 100, 200, so that you can insert some additional structures folders later if necessary. Once done, go to the data model and do it exactly the same way, like I prepared here already. And then another tip, if you have one of your data model folders, then assign here a default folder, because this makes development easier later. So you can click on a table and say right-click, develop or create interfaces in. That's something I'll show. Now, you know how you can structure your ODI projects. We can start to develop interfaces. Your project is structured, so we can start developing now. The basic element for data transformations in ODI is the interface. It is used to transfer data from source structures into target structures using various strategies which are defined, as you know, in the knowledge modules. There are various ways to create interfaces in ODI Studio. You can go to your project in a folder, right-click on Interfaces and select New Interface. Or what you can also do is you can right-click on a table and select Generate Interface In or Out, depending on you want this table to be the source or target of your interface. And the last way you can create interfaces is click on the model and select Generate Interfaces In. So this will create interfaces for all tables contained in the specific data model, again in or out, depending if you want the tables to be your source or your target data store. I will create an interface using the normal way now. As soon as you have your interface open, you have to give it a name. If you did choose one of the Generate Interfaces methods, then the name is already given. It is the word in followed by the table name and a version number. In most of the cases, 001 is the first version. By default, the interface is created in the default folder you have set in your model definition. I mentioned that earlier. As you can see in the interface, you have multiple tabs on the bottom of that page. Let's explain in detail which purpose they have, going into more detail then later. The Overview tab just contains the basic information of your interface, like the name and the ODI staging area. What you can do here also is you can add some descriptive information, which really makes sense, by the way. In the Mapping tab, you define the mappings of your transformation, like target column equals source column or target column equals sequence. You will see that later if I have added the source data store and the target data store. In the Quick Edit tabulator, as the name already says, You have fast access to nearly all configuration settings of your interface. You see it here, the sources, the lookups, the joins, the filters, and the mappings. In the Flow tab, you select your strategy, your knowledge modules. Means you choose here exactly what transformation strategy you want to apply to this specific interface. I have here a fatal critical error because I haven't added any source or target datasets. In the Controls tab, you define which flow or static checks should take place on your data using a CKM, a check knowledge module. Scenarios tab contains all deployed object versions from this interface, and the Execution tab shows all executions of this specific interface. Not the details, but the overview. Let's go back to the Overview tab. Once you have entered the name, selected the staging area, that's it for the Overview tab. So, just one remark, please note that the staging area definition will change as soon as we progress with our interface. So for now, we do not take care of that. In the Mapping Definition tab, what you do here is adding your source and target data stores, and obviously, as we're doing data transformation, some expression in the mappings. Let's load the table cCustomer in the staging area using the source table cCustomer. It'll be a pretty straightforward example. So I added the source data store now. Next thing is I'm adding the target data store. When asked for the auto mapping, just click OK. This maps the columns automatically if the name is identical. But be aware that lower and upper letters make a difference here. Let's assume we do an initial load, but we are not sure that all customers have status defined. So we add a null value function here in this status column. So we click on the column, and then in this property inspector window, we add NVL, open up the brackets, -1, which is a singleton value. That's it. When clicking on one function, ODI shows you the syntax and a short description of the function. If you want, for example, implement a sum on one column collapse aggregate, search for sum, double-click on it, and add the field. That's it. Be aware just that when you add a sum to your mapping, the group by is created automatically for you. Of course, you can also type some expressions like case when, coalesce, or similar. Every function supported by the underlying technology can be used here in the expression editor. The NVL null value function is now a mapping which will be executed by the interface. In this case, it's a function, but it can of course also be PL/SQL or a sequence defined in your database. You do that exactly as you would do in your database. If supported by the used technology, you can also click on the checkmark icon to let ODI check whether the expression entered is valid or not. You see it here. For our example, let's add a case statement. We want to have the singleton -1, customer not existing, added to the cust ID column for the case there is no value for cust ID in our source data. So we click on the column cust ID, open up the expression editor, and enter case when is null, then -1, else, custom ID, double click, and this is our statement. If you want, of course, you can format it more beautiful whatsoever. Let's check whether the expression is valid. It is, so we are fine. Below the implementation window, where we have now our case when formula, there is the execution location, which you can see here. And then there are some interesting checkboxes. Insert and update, which is defining whether this column should be included in an insert statement or an update statement, or both of them. Then you have the definition of your target column. Then you have the already mentioned key checkbox, which is indicating that this is our key. In this case, custom ID is our key. And then you have the check not null checkbox, which is responsible for checking your data in the flow using a CKM, a check knowledge module. On top of that you have some user-defined flags, which are partly used by your knowledge modules. So If so, then you have some hints on that in your knowledge module description. Now we have to decide which strategy we want to use to integrate our data into the customer table. We change to the Flow tab, activate the target data store, and select the IKM SQL control append, which is already selected here. This is our integration strategy in this example, but there are many others implemented for you in the library of knowledge modules. Of course, we can also use another knowledge module here, which is implementing, for example, SCD, slowly changing dimensions handling, or constructing a merge. Please take a look at the various numbers of knowledge modules available. There's most certainly one for you needs existing, though it might be necessary to adopt it to fit your requirements. Please be aware that some knowledge modules require alternative keys be set in interfaces. This can be done in the Property Inspector by clicking on the key checkbox. Default keys are those which are defined in your model, but you can always overrule that by just adding them to your mapping. After setting the knowledge module, we go to your options in the lower window and change truncate to true, as we do in initial load. Let's execute the interface and inspect the execution log. For this, click on the play symbol, choose the local agent no agent, and click on OK. Change to the tabulator after the confirmation and open collapse date. Unfold the execution, and you see that the execution was successful. Here you can inspect the generated code of the steps contained in the knowledge module. This you can reach by double-clicking on the steps executed and changing to the Code tab. Let's take a look at the Insert New Rows step. You see here 8 rows have been inserted of total 8 rows, and if you click here on Code, you see what the exact statement has been. You can always execute the query again, see the execution plan, and so on by clicking on Query Execution Plan. Let's wrap up. In the Overview tab, you define the name and you can override the ODI staging area definition. In the Mapping tab are the critical parts. Here you define source and target data stores as well as the mappings itself, also known as the expressions executed. In the Flow tab, you apply the strategy. If you have multiple data sources, you'll see here also multiple load knowledge modules. In the Check tab, you can define a CKM, a check knowledge module, to let your data be checked. So these are the basics regarding the interface. Next chapter covers filters, joins, datasets, and sequences. Now that you know how to create interfaces, in general, you also should get familiar with additional utilities, making developing an ODI easier. Let's talk about joins first. Of course, you need to join multiple data sources in ODI as well. If you want to do this, you can simply add additional data stores from your model's accordion to your source canvas. Afterwards, you can drag and drop a column from one source on top of a column from the second source to create your join. Let's add another source to one interface and create a join. For this, I opened this interface here. I want to load the clans customer table, but with the surrogate key column data warehouse ID here from my C customer version table. So I add the D customer version table to my source canvas, and for the auto mapping I can say yes, as I want the data warehouse ID to be mapped there. And next thing I have to do is I have to create the join. So what I do is I drag the customer ID on top of the other customer ID and have a join here. And here in my property inspector then I can add the join condition, in fact, and of course also the join type. Left outer join, full join, right outer join, and so on. That's it for the join. Next are filters. Obviously, you need to filter some of your data to reduce data volume and do transformations reflecting the business processes. This is a little different in ODI. Let's filter our customers so that we only get active customers. In the mapping canvas, drag the column status from your cleanse table and drop it on the canvas. This creates a filter, which you can then adjust or adapt in your property inspector. You can always test your filter by right-clicking on it and selecting Data. You see here 2 of my customers are active. Next in the row are datasets. Datasets are additional sets of data which you might need, for example, if you have similar data you need to combine using a union operator. What you can do here beside of union is you can do a union all, you can minus, that means you can really retrieve or detect the differences between 2 datasets or subtract one dataset from another. And you can also have the intersect, means the mix of all 2 datasets. Be aware that here the same limitations are valid as you're used to in the normal SQL statement, means the form of both datasets has to be exactly identical. Once you have added the second dataset, you have another tab here, which you can then fill also by dragging your data stores to it. This, for example, could be an example for a minus. I want to have only rows which are not existing already in my version table. So I'm adding this column here, my target column, to the source. And in my operator here, I select the minus. By doing so, it really creates a minus, means he's subtracting all existing rows. Last we have in this chapter are sequences. Sequences, you might already know from the databases, are automatically incremented counters used to keep key values unique. They can be used in every mapping, independent whether you define them in ODI or not. You can at any time use native database sequences in your ODI mappings as you're used to have them in your database, in your SQL statement. So, joins are normal business and data warehouse environments and easy to create in ODI. You can even define heterogeneous joins against federated data servers if required. Filters are necessary to limit data and reduce data volume, but also to reflect business processes. Datasets are needed to combine similar data from various sources in one single transformation, and sequences, finally, are used to keep surrogate keys in data warehouse tables unique. In the next chapter, you learn details about temporary interfaces and lookups. There are sometimes cases where you need to cascade interfaces, as the complexity in your source is not sufficient enough to provide the flow input. There are sometimes cases where you need to cascade interfaces, as the complexity of your normal source is not sufficient enough to form the flow input. For these cases, you can use temporary interfaces. These temporary interfaces can be used as input for other interfaces or even for lookups. They can be created very easily by just adding no target data store to your interface, but instead writing a temporary table to the ODI staging area. You do this in the Mapping tab by adding a name to the target data store. You have to click on the temporary target data store, and then you can add a name here. Now you can drag and drop columns to your temporary target data store as you need. Please note the yellow exclamation mark in the interface. As soon as you have errors or warnings, you'll get this symbol. If you click on it, you'll have the explanation of your errors, and in most cases, you also get a fix recommended. We leave this for now. Next are lookups. They are the standard in data warehousing to derive primary keys from a dimension table when integrating into a fact table. In ODI, within the mapping of your interface, you can create a new lookup by clicking on the glass symbol. Next, you define the driving and the lookup table. The driving table is the source table from which one column value is the value to be lookuped. The lookup table typically is a dimension table, for example the customer table. Let's assume we want to load a fact table, and for this we need to look up the correct primary key from the customer dimension table. I prepared this interface for that. As you can see, this interface, we have one source table. Let's assume we want to load a fact table, and for this we need to look up the correct primary key from the customer dimension table. For this, I prepared this interface. As you can see in it, we have one source table, which is the source fact table, and we want to integrate its data into our fact table in the core area. Now we add a lookup for the customer dimension table. As we want to have the actual version, we use the version table. Next is that we define the join, and we decide that we want to have that happen in the ODI staging area. You see here customer ID from the driving table equals customer ID from the dimension table. Click on Finish, and you'll have the lookup. Of course, you can unfold that and make it bigger as you want it. Now you know details about lookups and temporary interfaces. Next section is about knowledge modules in detail. You know the agents of the ODI world now and how to execute. That was simple so far, but now it's getting a little more complex. The execution locations come into play. You'll surely ask yourself, what are execution locations? As you might perhaps have noticed in ODI, not all but nearly all objects can be executed in 3 different locations. On the source data store, in the ODI staging area, or on the target store. What does that mean now? You as a developer can decide where you want to execute, for example, a join, or a filter, a group by, or a mapping. Better, an expression as we know. That makes it a little tricky, but adds a lot of functionality to ODI, as you can really define what's best fit for some specific kind of transformation. Nevertheless, there are some limitations, as you can see here. Join and filter objects cannot be executed on the target. Everything else is possible. If you want to change the execution location to one of your objects, you can always go to the mappings tabulator. You can choose the object you want to change and then change the execution location. I'll show that on one simple interface. Open the interface, go to the mapping tab, select one mapping, and there you go. You have the execution location, and you can change between source, staging area, or target. And the same you can see if you, for example, create a filter. For the filter, then you have also the possibility to change source and staging area. And you see here, there's a limitation. You cannot execute the filter on your target data server. So you know now the execution locations. Keep the limitations and possibilities in mind. And be aware that using execution locations makes development in ODI fun, but also lets you lose overview fast. So try to follow the KISS rule. Keep it simple, stupid. In the next section, you'll learn about the other development objects in ODI, the packages, procedures, and functions. In this section 3, it's all about your data transformation strategies in the knowledge modules. We're going to take a look at adapting knowledge modules to your needs, how to execute an ODI using the different agents, execution locations and its meaning. This is a chapter describing the basics about adapting the knowledge modules to your needs. As you already know, the knowledge modules are code templates containing the strategy you want to apply to your data integration tasks. Let's take a look at a knowledge module. Each knowledge module has a description, explaining in short what its purpose is and what functionality is supported. In the Details tab, you'll see all commands which are contained in this knowledge module. You see here ODI staging tables, work table is dropped and then recreated, then data is loaded into it, analyzed, and then in the end the work table is dropped again, all depending on options. Let's open one command. Each command can have 2 commands in fact, a source and a target command. This is one very useful approach, as you can pass over values from the source command, in this case here it's a select statement. You can pass it over to the target command, which is an insert statement. And this all is happening using bind variables. Bind variables can be identified by the colon. As you can see here, you can decide which technology you want to use in a command. You can also mix technologies between the commands. If the technology is set to undefined, this means that this command can be run against all technologies. That means it's generally valid for all technologies. To make knowledge modules usable in a generic way, substitution methods are used. You can recognize the substitution method by this less than, percentage, equals, ODI ref, followed by the point, and then the function. Of course, added with various parameters to be submitted. The substitution method ends with the percent symbol and the greater than symbol. Logging can be structured by setting the log counter. You can decide whether the command step is logged to the update, insert, delete, or error log counter. Also, of course, you can decrease the log level. If you check the log final command, the complete code generated by this command step is logged to your logs, which makes it much easier to analyze potential errors. Also, other parameters can be adjusted, for example, the commit levels. In this case here, the transaction is auto-committed, but if you set it to one specific transaction, you can decide whether in this command the commit should happen or not. And of course, what you can also do is you can define a number of rows after the transaction should be committed. Last but not least, you can decide whether an error within this command stops the execution of the complete knowledge module by checking this checkbox Ignore Errors. The usage of options can influence code generation from the knowledge module tremendously. You'll find it under the command step, where is a list of options, and you can control which command is executed depending on the values of these options. For example, only if the validate option is checked here, this command step, is executed. If you want to add options to your knowledge module, you can easily do that by right-clicking on your knowledge module and selecting New Option. Nearly all knowledge modules have a group of standard options. I'll open another IKM, another knowledge module here, this IKM SQL control append, and I'll show the options. The most common options are the truncate option, the delete all option, and flow control and static control. Flow control and static control coming later if we talk about data quality control checks. There they are used very frequently. Be aware that within this code templates you are free to mix up various technologies. You can, for example, generate conditional code using variables. You can take the values from your source and take it over, transfer it to the target command. So doing this, you can easily reach an insert as select statement. So in the end, in the knowledge modules, there is no limit. You can implement whatever you need. What you should take from this chapter is that there are substitution methods used in ODI to make it possible to generate code in a generic way. As this generic approach is very useful and these substitution methods can be used nearly everywhere in ODI, you should consider using them frequently. I just want to reference the ODI knowledge module documentation, which you can find under this link, and there's also a white paper from Uli Bethke demonstrating how to develop your own knowledge module. It is based on ODI version 10, but since then there hasn't changed a lot in developing your own knowledge modules. In this next chapter, you'll learn something about execution of ODI objects and the agents needed for that. Now that you know at least the basics of how to change knowledge modules, you'll learn something about the execution. In ODI, it's all about agents when it comes to execution. Basically, there are two types of agents, the scheduler and the execution agent. The scheduler agent executes triggered by a time event. The execution agent listens for new requests. Agents in ODI orchestrate the integration process. They are the pieces of code which are interacting with the data servers to execute generated code. Of course, they also update the execution log. Be aware that agents must be declared in the topology. Physical agents are representing components at runtime. They have to be abstracted as logical agents and are then addressed using the context. Agents can be deployed into some application server, as WebLogic Server, for example, is one, or they can be started standalone, only requiring a functional Java installation. As of now, you only know the local agent no agent from your ODI Studio. It in fact is no real agent, as it started when you want to execute something and ends once finished with the job. So how do we define a local standalone agent? It's simple. There is one batch file with the name agent.bat agent.sh for shell script, which you have to call to start an agent. It has two parameters, the agent name and the port it listens to. Additionally, it sets other required parameters from the file ODI params batch or shell. Within this file, there are all necessary informations for connecting to the repositories needed. Once the agent is started, you can also start scenarios from the command line by issuing the command start san bat or start san shell, passing the agent URL as a parameter. On top of that, every Java agent comes with the capability to handle web services. Hence, you can also use this functionality to start your scenarios. Within the parameter file, you have to add the log and verbose level of your agent. Depending on the value, more or less details are logged. Just one thing, if you have scheduled some jobs, you have to manually update the schedule against the agent, otherwise your changes are lost. Reason is that the schedule is only updated when the agent is started or updated via exactly that button. I show you in ODI Studio, you go to the second tab, which is Operator tab. There's a scheduling, and there you have your agents where you can see the schedules and you can also update the schedules. If you're interested in knowing exactly how to set up an agent on a server where Java is running, please consider doing this exercise here from Oracle by example. Now that you know everything about executing, you'll get familiar with another feature, the execution locations. This section 4 is all about workflows in ODI. We're going to take a look at the differences between procedures, packages, and functions. We'll show some use cases for packages. You'll see reusable workflows, the procedures. User functions are useful functions. And how to customize development objects in ODI using variables and options. We had a little excursion on knowledge modules and agents in the last section. Now we are getting back to developing. Next development object you'll learn about are packages. Packages are the containers in ODI which are used to form workflows. In fact, they are an organized sequence of many steps making up small tasks. What are use cases for packages? The implementation of a process to load a folder with flat files, for example, which is a process with a loop in it, as you have to process multiple files in exactly the same package step. Each package has exactly one starting point, but can have multiple exit points depending on the number of exits you want to define. To create a package in ODI is very easy. Go to your project, right-click on Packages and select New Package. Give the package a name and change to the Diagram tab. The package is built of steps, which can be sequenced. Typical package steps are interfaces or ODI tool steps. Again, here you can drag and drop objects to the diagram canvas to add those as package steps. As you can see in the diagram, you'll have the ODI tools on the left-hand side. ODI tools are small macros providing useful functions like send email, wait for file, unzip file, zip file, and so on and so forth. These tools can be used as steps in an ODI package. As you can see here, you also can use operating system commands. Be aware that the behavior in this ODI development object is different. You have to select the ODI tool first and then can add it to your diagram by clicking into the empty canvas. Of course, if you click multiple times in your canvas, you'll have the ODI tool step in your package multiple times. So let's do that for one simple step. Let's add one tool step, which is sending an email. Send email can be found in the internet section here. You have to search for it. There it is. I click on it and then you see this little target you click on your empty canvas and then you have added it to your package. Click back to it and then you can enter all the parameters to it. So your mail server, my mail server dot mydomain.com, from me at mydomain.com, and I have to add an address list, and I say not me at mydomain.com. Then I can of course add a CC and a BCC. What I at any time want is a subject. Data warehouse load was successful, for example. I can add an attachment if necessary, and of course I can add a body. For example, this is an automatically generated mail. Do not reply. Okay, that's it for this. You can at any time rename this tool step. For example, data warehouse load successful. And here you go, you have it. Just to point out one difference between a package and a procedure. You can rename all the package steps, you can bring them in the order of sequence, but these package steps are not reusable. If you want some reusable components, you'll need a procedure. But let's finish our workflow for now. What we need is an interface, of course. We want to do some data transformation, so we add an interface to this package. And we have one success mail, but we also want an error mail. So I click on the ODI send mail, ODI tool again, and I add it to my empty canvas. I click on my pointer here, and then on the object I just added, and rename data warehouse load error. That's it. I'll skip the other parameters as they are the same as demonstrated before. So in order to have a workflow run in the order of sequence, there are two ways to do that. Click on the OK symbol and connect the various tool steps. Okay. Click on the KO, which is the error case, and connect the different workflow steps. I mentioned the loop before, so how can I create a loop now? You can at any time do that by adding a variable to your diagram and use the various methods linked to that variable. You can evaluate it, you can refresh a variable, you can declare it, you can set increment your variable. As the name variable already says, we use it to develop our transformation tasks more dynamically. Though not well introduced so far, I just want to add one variable to show how this is running. So in my project, I'm searching for the variables, and I have a simple counter variable here. I'll add it to the package, and you see, if I add it, I have the various types. I can set the variable, I can declare it, evaluate, and refresh it. I also prepared a little package to show you how this is running, how this can look like in the end. It could look like this. You have a starting procedure. You have a counter which is set to 1. Then you have a looping procedure where you, for example, load different files with different file endings whatsoever. You're increasing the counter. You see set variable and there is an increment by 1. You'll have an evaluate variable where you're evaluating, you're checking the value of that variable. And depending on the result of that check, you're going back to the looping procedure or you're exiting your package, going to the ending procedure. And then in the end, after all the files have been loaded into some staging area, there's one staging interface then executed as a final command. That's it for the packages. Next are the reusable workflows, the procedures. Workflows are handled. Now we are talking procedures, the containers which can be reused. What is a procedure then? By structure, it is basically the same as a knowledge module. as it contains commands executed by a database system, the operating system, or other service providers. But in the end, it's reusable and therefore designed to deliver a utility for repeatable tasks. As such, it can obviously be inserted into packages. A typical use case for a procedure would be a script necessary to connect to a network drive, or some email procedures which should be used everywhere throughout your data warehouse loads. So, if the procedure is similar to a knowledge module, what's the difference then? Basically, knowledge modules are more data related, while procedures are more process related. You can even execute ODI tool steps in your procedures. Let's create a simple procedure in ODI Studio. Right-click on Procedures in your project, select New Procedure, give your procedure a name, and that's it for the beginning. Then you can decide whether this procedure is valid or running for a specific set of technologies, or you let it on undefined. That means it is running for all technologies. Let's add one single command to that. For example, map network drive. You can of course add here a log counter. Doesn't make sense in this example. And then you can define the technology used. You can define the logical schema here as soon as you have, for example, selected a technology here. And then you have your topology listed up. You can define the context if you want to really limit it to that context. That means this procedure is always executed in this context. Means the context definition here is overwriting the context you select when you're executing, for example, this procedure. And what you can always do is you can click on Ignore Errors. What's possible with procedures? You can run SQL statement, operating system commands, you can use ODI tools, or create and execute Jython, means a combination of Java and Python programs from within your procedures. In the procedures, it's also possible to access variables, user functions, and sequences. Options are influencing the result of a procedure as well, as execution of commands can happen only depending on the value. I want to show you an example how procedures look like in ODI. So I open this one here. As you can see, we have multiple commands. And also here, not only in the knowledge modules, you can pass over the values from the source command over to the target command if wanted. You see it here, different command sets. I mentioned it in a very early stage of this ODI screencast, but want to memorize it again. In ODI, whenever you embed ODI objects into other objects, for example interfaces in packages, you only reference them. They are not copied. This is the reason that later changes do not create a lot of manual effort related to necessary manual rework. In the next chapter, you'll learn something about the user functions. After packages and procedures, the next new utility are user functions. User functions are macros defined in a lightweight syntax, used as alias for a recurrent piece of code or to encapsulate a customized transformation. They are used to provide utilities which are usable across all technologies. Use cases for user functions are, for example, a standardized syntax for a null value function or a recurring function to cast state fields. User functions always have a syntax, several implementations, and a scope, which could be global or project. They are organized in groups, which you can define yourself. Of course, user functions are design time objects, means at runtime you only see the implementation of the user function, means of the underlying technology in your execution log. So let's create a user function. We want to develop a utility to have a standardized value for the case that we have null values somewhere. So we go to our project, right-click on user functions and select new user function. Of course, you can also go to the global objects, accordion, and click on global user functions and select new user function. Afterwards, we give this user function a name. I prepared already one user function, so I want to open that one. So we give the user function a name, and then we can enter the group name by ourselves. This you can override, so you can select really which group name you want. After you have entered the name and the user function group name, you have to enter the syntax. In this case, I decided to have an if null, and I'll pass over a compare value and a singleton value. Of course, you can leave out the singleton value and replace it with a default value. However, this is up to you. Once the syntax is defined, we go to the Implementations tab. And here you click on the plus, which I already did for the Oracle part. In the Implementations tab here, what I do is I implemented it something like a case when compare value is null, then singleton, else he's returning the compare value. This is running, I would say, for pretty every database. It is a general approach, and case when, I think, is supported by every database. So in Oracle, though, it would be a little bit different, because you can normally also write it something like this. Here you go. And that would be the implementation for the Oracle technology. This is running, but not running with the Microsoft part, for example. As mentioned, you can of course leave out the singleton and can replace that simply by a -1. Then that means you don't pass over the parameter with the singleton. You see, this is the principle of user functions. Very useful little helpers. You should make use of it. Be aware they really can help you making everything much, much easier. In the next chapter, you learn something about possible ways to customize all the previously mentioned ODI development objects by using variables and options. So, in this chapter, we make the packages, procedures, and functions more dynamically usable by inserting variables and options. As the names already say, variables can be used to insert values dynamically depending either some logic or on refreshing mechanisms. Basically, you can use variables everywhere in ODI. It's even possible to have parts of your topology definition dynamic by using variables. Also in the package you can use variables. I mentioned that in a previous chapter. You can update, increment them, set them, evaluate them, or declare them. The difference between declare and set is that with the declare, you publish the will to use them only. With the set, you really assign a value to them. As you can imagine, variables are a good way to create loops then. I'll show that. Packages, loop package. If I change to the diagram, you'll see a perfect loop. So you can use the variables in an evaluate step and branch out depending on the result. A simple example you can see here. The variable is set to 1. Then the looping procedure is executed. Then the counter is incremented by 1. Then the counter is evaluated. Depending on the result, if the counter is less than 10, then the looping procedure is executed again. If the counter is not less than 10, he's jumping over to the ending procedure. So this is an easy loop package, and this is the way variables can be used in ODI. But how do we define variables? Of course, we can define them as a project variable or a global variable, and this really makes up our mind whether it should be global or project scope we want to use. So right-click on a variable in the project and select New Variable. We can give it a name. We can decide for the data type we want to use, alphanumeric, text, numeric, or a date. We can define a default value, and we can enter a description if we want to. So this is pretty much the definition of our variable. Next interesting thing is we can use some refreshing mechanism in this refreshing tab. For this, we have to enter a database schema, a logical schema here. And then we can enter some command. Select whatever, sysdate from dual, or select my table from server sources. You can do pretty much everything here. So you see, variables are really a useful thing. Next in the list are options. As you might remember, you can add options to knowledge modules, but not only there. You can also add them to your procedures, making the execution of certain commands dependent on the value of your option. So I did that here. And if you take a look at the details, I'll add an option now. Add new option, my option, type, checkbox, it's true. And now I can double click on my archive files and say, I don't want to have that executed always, but only if this option is true. So you remember that from the knowledge modules. It's the same here with the procedures. Of course, you can also take the values, retrieve the values of the options in your commands by simply using something like a hashtag and then your option name. Would be pretty much like that. So that's everything about variables and options. In the next section, you'll see how you can integrate data quality into ODI integration tasks and how delta detection could be implemented in ODI. This section 5 is about data quality and delta detection. We're going to take a look at Oracle data quality products, data integrity controls, how to integrate data quality into ODI, delta detection using CDC, change data capture, and other possibilities like Golden Gate. As mentioned, this chapter is about data quality. There are quite some tools out there to do that. Even Oracle offered multiple possibilities over the years. There was a time when they had a Golden Gate product, the good old data quality option coming along with the Oracle Warehouse Builder, and then Datanomics separately. In the meantime, they have integrated it all into one product suite, the Oracle Enterprise Data Quality Option, EDQ. But the older versions of data quality and profiling are still available. EDQ jobs can be integrated into ODI packages without a problem. Results from it can be transferred back into the data flow of the package and consequently be transformed in subsequent data integration steps. We'll see how this is running in the next chapter. For now, we focus on the data quality checks built into ODI. So let's start with the data model. Here you can already check a lot of things out of the box. First, you can analyze the number of rows contained in a table. I'll show that in ODI Studio. Open the models, Data Warehouse Project, one folder, then one table, for example this one, and then click on this arrow and you see the total number of rows. From version 11 on, the number is stored for future use so that you can see if the number has changed over time. Next we can do is check the validity of constraints defined. For this, we change to the core area as there typically constraints are defined. Double-click a constraint and change to the Control tab. In this case, I check foreign key constraint and Control to the Control tab. For each constraint in the data model, you can define whether they should be checked actively in the flow and the static section. Flow means data is checked before data is flowing into the target. Static check means the data is checked after it has been integrated into the target data store. You can always click on the check and really check whether all your controls are okay, are valid. On column constraints, you can define how you want to process errors. You can reject them or put a null in this column. The letter, active or inactive. You see that if you open up the columns, if you choose the primary key and then go to the Control tab, and you see here you can choose for reject errors, null if error inactive or active. Table constraints can be defined in the database or in ODI. Primary keys, for example, can also be checked for duplicate entries. So the primary key definition you see here, and you see that it can be defined in the database and it can be set by you to active. You remember the options in your interface. Options like flow control and static control trigger data integrity checks. You can recycle erroneous rows back into your flow. The option recycle errors is a switch for that. Errors are saved in $$ tables within the ODI staging area. All these checks can be customized to your needs in so-called check knowledge modules, CKMs. So I'll open one CKM for you, and you see how it is running. This CKM is responsible to create error tables, and it implements your checks. You see here, if you have errors with your alternate keys, your foreign keys, and so on and so forth, this is implemented in these steps. And the errors are then inserted into your error table, your temporary error table. There is quite some data quality check functionality built into ODI, but it's not complete. Be aware of the limitations. You can only define static and flow controls out of one CKM, exactly that CKM you see here if you use that CKM in your interface. In the next chapter, you'll see the more sophisticated way to do data quality testing using the Enterprise Data Quality tool from Oracle. As mentioned, there are some data quality checks built into ODI. In this chapter, you'll see how you can embed existing EDQ jobs into ODI. Now, packages. And packages are the container for EDQ jobs. You can simply drag and drop them into your package and they are executed. Nevertheless, you have to define those tasks within EDQ Enterprise Data Quality tool directly. You can define all your EDQ tasks by using the director, which you can open from the browser. This is the Enterprise Data Quality Launchpad, and if you click on the director, you'll be led into this application. And here you can define your projects, and in your project, all the different data stores. You can do some profiling and auditing, parsing and standardization, match and merge, and many others. So all of these can be retrieved back into ODI, all of these data quality jobs, and can there be executed along with other data integration tasks in our packages. As you are used to from the packages, you can use sequences, you can sequence and bring them in the correct order, the processes, and make execution dependent on prior package steps and all that. So what you have to understand is to integrate EDQ jobs into ODI, there is a separate tool necessary, and if you have defined those steps, then you can really just create a package, and there you have in the diagram tab, you have new plugin, and if you click on that and then in your diagram, you can add an enterprise data quality job, and here in the properties, you can then define the job name, the project name, and everything you need, and then you can execute it, and the results of that are coming back into our ODI package then. So the out-of-the-box functionality in ODI is limited, but not this bad by default. To implement more complex data quality tasks, EDQ can be used and the results of your data quality achievements be loaded back into the normal data integration processes. The next chapter then is about change data capture and how you can reach that in ODI. So I want to show how this is running in EDQ. For this, open up Enterprise Data Quality application. Of course, you have to install it first, but if you installed it, you have this screen here, this web page, and from here you can start the director, which I already did here in the background. Here you're defining your projects. I defined data warehouse, data quality tasks here, and you can add the data stores you want to cleanse or you want to apply transformations against. So I added a data store here, which is my data warehouse source. I have some stage data, means there's an intermediate, a template copy of my data. I added the source customer table here, and you see I have embedded a little error, which I want to cleanse. I want to remove the 2 slashes at the end of this customer 4714 in this example. So I defined a process which looks like that. I have a reader. This reader is reading my source table, this one here. All the reader input is running into a profiler. This profiler tool is passing over the values to the next tool, which is an invalid character check. If you click on that, you'll see there are 7 rows which have valid content and 1 row is having invalid content. If I click on that, I'll see exactly my 1 row. So what I did then is I connected the valid exit of this tool to my writer, and with my writer I'm creating a table which is called customer cleansed, and this customer cleansed is not having the slashes anymore. To integrate that cleansed job now into my ODI, I'm having a package called cleanse data warehouse, and in the diagram I added that cleanse customers tool step. As you can see here, I have to enter the exact name of my EDQ job, of my EDQ project. Then I have to add the server name and the port. The port is always 9005 if you have not changed it during the installation. And your username and the password. And then you have to decide whether you want to execute that job in a synchronous mode or an asynchronous mode. What I will do now is I will execute that. It was all run, and I have now the proper content in my cleansed customer table. If you do not have any timestamp columns within your data sources and you need to transform only change data, you are dependent on other solutions. Within ODI, you get one for free. In fact, there are 2 CDC change data capture methods implemented in ODI knowledge modules. CDC in ODI is based upon journal tables. The knowledge module creates a journal table with a very basic structure in it. A primary key to detect changed records, a timestamp to record lost change, and a flag to allow for locking of records. Afterwards, a series of views is created, which are acting as utility to derive the changed records. You get 2 methods, the simple and the consistent CDC. As the name already says, the simple one is not usable, as changes happening during data is transformed are not recorded and therefore lost. This can result in missing references. The consistent CDC, on the other hand, closes this problem by using windows. During the transformation of data, changes are recorded in a new window and therefore be processed in the next execution. So how do you do that in ODI? First of all, as always in ODI, you need a knowledge module available. In this case, it's a journalization knowledge module. I imported already one here. Just for demonstration purposes, it's a simple one. Of course, you will have other knowledge modules which are just for the purpose of journalization, as you can see here. Next thing we have to do to reach CDC journalization is we have to assign that JKM to our data model. So double-click on the data model, change to journalizing, and assign the JKM here. Save it. That's it. We just defined that this data model is using this exact strategy. So, next thing we have to do is we have to add a table to our subscriber. So, right mouse click on the table, change data capture, subscriber, subscribe. And then we have to enter the name of a subscriber here. And then click on the plus and OK. The agent is running. This is normal. we can check that everything went through fine. And we can see it's still running, but it'll go out good in the end. That's fine. Perfect. Afterwards, we have to add the table to the journal. So right mouse click, change data capture, add to CDC, and confirm by clicking on yes. Now you see a little yellow clock left to the name of your table. And the last thing we have to do is we have to start the journaling for this table, add the subscriber, and click on OK, and confirm the agent, and the agent then is starting. And now you see a green clock beside of the table, and that means journalizing has been started. As soon as I change something now on the table, it will be protocoled into my journal table. Whenever you now add this table to your interface, you will have a filter added automatically to your interface, which is filtering only journalized or changed data. Beside of that normal journalization possibility feature, you also can use, of course, Golden Gate, streams, triggers, and so many more. There's a bunch of functionality inside it. So just to sum up, you have to decide for the strategy, in fact, the knowledge module, then you have to create a subscriber, then add the table to it, and add the table to the journal and start the journal. That's the way. In the next section, you'll learn something about version management and deployment. ODI comes with a simple version management. I want to show you in this section what different possibilities you have. A little excursion to the repositories. You must know that you have three types of them: the master, the work, and the execution repository. Be aware that versions are stored in the master repository, while the actual version is contained in the work repository. Versioning is possible with all development objects in ODI. In the end, you can version everything in the Designer tab. So let's take a look in ODI Studio how this is running. If you, for example, have one interface, right-click on it, go to the version menu and select Create Version. There you can, for example, create a version with the actual date. Be aware that you can always get back a previous version from the master repository by right-clicking on an object, select Version, and say Restore. Then you can choose one of the versions existing for this specific object. On top, you can compare between versions, which is running here. I want to compare this actual version now, for example, with version number 2013-12-31. What I get there is the differences which are highlighted. I can decide how to filter the objects. I want to see only deleted parts, new parts, modified parts, or unchanged parts. The smallest deployable unit in ODI is a scenario. In the next chapter you'll learn more about them. The scenarios can also be versioned. You have a version browser where you can go through the different versions existing. The version browser can be found on the right upper edge and then under version browser. If you click on it, you see all existing versions in your master repository. In fact, here I have the data warehouse project for which two versions are existing, 1000 and 1001, and I can go through them and select the various objects. Since version ODI 11, there is another feature available, the release tag. You can reach it nearly the same place as the version browser. It's here, and then by clicking on Edit Release Tag. You can add a release tag, for example, like this, and then, once in that wizard, you can select the various objects you want to bundle into that release. Later on then, you can use these release tag as an indicator for your release and do the deployment with only objects having this specific release tag. In ODI, you have versions everywhere. In each development object, you have a separate tab called Versions. So if you click on that, for example, you see here there's a tab with versions, and there you of course can add your new version to that object. You see, you have a lot of functionality in ODI for versioning. What's missing though is a connection to an external versioning system like current version system or any other software like that. For most of the requirements though, it's enough what we have in ODI. In the next chapter, you'll learn more about the scenarios, the smallest deployable unit in ODI. The smallest deployable unit in ODI is a scenario. Within this chapter, you'll learn more about those scenarios. You can create scenarios by right-clicking on an interface, package, or procedure. What you can also do is you can create all scenarios contained in one for all the objects contained in one project by right-clicking on the project and selecting Generate All Scenarios. The scenario contains executable code addressing the topology on a logical level. It contains no references to other ODI objects. The codes are frozen and afterwards changes, for example on knowledge modules, are not reflected any longer. So, once a scenario is created, you can do only the following things with them. I create one now. I take one interface, generate scenario, and you see you have the name and an automatically created version. Once a scenario is created, you can only do the following things with them. You can execute it, regenerate it, and that's it. Regenerating of a scenario cannot be undone. That means if you want to keep a version, you should create a new scenario from the original object using a new version number. What you can also do is you can click on the folder and say generate all scenarios, and then you're prompted for the generation mode. And as you can see here, you have 3 different generation modes: replace, regenerate, and creation. You can also decide for which objects you want to apply this generation mode. But what does the different generation modes mean? Replace is an unstoppable action. It replaces a scenario with the same name, the same ID, and the same version. All historical information on this scenario are deleted, like for example execution logs, sessions, and so on. If no scenario exists, one is created with version number 001. If you select Regenerate, this means the last scenario is overwritten with the same name, the same version, and the same ID, but the history is kept. So that means you have the execution logs, the sessions, and of course the reports if this is necessary. If no scenario exists already, one is created exactly the same way with version 001. If you select Creation only, that means only new scenarios are created with a new version number. Means if the old version number is 001, it will increment this number up and creates a version 002. If no scenario exists in this case, one is created with version number 001. If scenarios do contain variables, you can decide how you want to handle them. For example, I create one scenario from this one here. Now with version 2. You can make them a startup parameter. Means you have to pass the values over to the scenario before you start it. Or you can handle them directly in the package variable step. So I'll create a scenario from this package. And as you can see, I have one variable in there, and I can here really decide what to do with that. I want to handle it as a startup parameter or not, and click on OK. Scenarios once created can then be scheduled standalone or added to a load plan with the possibility to add that load plan to a scheduler. As mentioned, scenarios are the smallest deployable unit in ODI. This you have to memorize. They are self-contained. All references are resolved. The only things you can do with them is execute or regenerate them. In the next chapter, it's all about solutions. You know now about scenarios. Next, to make your development easier, are solutions. A solution is the ODI term for a configuration. Within a solution, you have references to objects' versions. These are called solution elements. ODI allows for picking principal elements and detects objects which are dependent of those principal elements. These are listed in the requirement Elements section. You find solutions in ODI Studio in a separate accordion in the Designer tab. On the right upper edge of this accordion near the 1.0, you can create a new solution by selecting New Solution. After giving the solution a name, you can add the principal elements to it by dragging and dropping it. In this case, I take the complete data warehouse project. You'll be prompted for a version, which I use as default here. Principal elements, for example, are projects, project folders, models, model folders, and so on. And he's asking always if I want to check in versions for all those objects automatically, and I choose yes. What he's doing in the background is he scans through the ODI object dependencies and adds those objects which are necessary to do the complete deployment. When doing this, ODI checks in master repository whether a version of the ODI object already exists with exactly the same properties. If this is the case, this version is taken. If not, a new version is created and you'll be prompted to enter some more details, as you saw in the windows before. Whenever you change the solution content, for example by removing or adding principal elements, you have to synchronize. This can lead to more required elements or to less required elements, depending on whether these elements become obsolete or not. It's even possible to version solutions, so you can really satisfy a lot of requirements with this feature. Restore therefore means this specific solution is restored back from master repository, and restore all means that all elements contained in this solution are restored from the master repository. You see, solutions could be a good solution for some of the requirements you have regarding deployment. In the next chapter, we talk about export-import and ODI internal IDs. This is a chapter about export and import, the most favored deployment method under ODI developers. I'll explain how this is all running. In ODI, you can in fact export and import nearly every object. Knowledge modules, interfaces, procedures, packages, sequences, everything. Just right-click on it and select Export or Import. What you'll get is a simple XML file. So I'll do that for an example here. I'll take one interface and export it to the desktop. And then I can show you the desktop. And as you can see here, you'll have a simple XML file with the structures of a typical interface. This, of course, you can use and customize it. Beside of the normal export-import, there's a new feature in ODI 11, which is a smart export-import. It is designed to be the solution for rapid deployment. I mentioned the release tags earlier. What you can do is you can use them as a parameter for the smart export and therefore only deploy these exact list of objects. Smart export-import can be reached from the right outer edge of the project accordion. Once clicked, you can select Smart Export, and if you click on this little blue arrow, you can define which release tag you want to take as your release bundle. Once entered the release tag, he's detecting all the related objects, and then you can export everything. In your target repository, for example your test or production environment, you can then do the smart import following the same procedure. You click here, select Import, Smart Import, you click OK, you select the folder where you saved your export file, click on Next, and then you can decide what import actions you want to follow. You can decide object by object what you want to do with all these various objects. You can merge them, you can override them, you can create copies, you can reuse them, you can ignore them. These are really the options you have. Once there will be conflicts, then you have again various options to resolve them. You can choose between ignore, change, do not change, or fix broken links. These are really used to resolve the dependencies. Export-import. Whatever you want, you have it in ODI. But please pay close attention to the ODI internal IDs. They make trouble sometimes. In the next chapter, you'll see some details around load plans, the ODI repository tables, and security. Section 7 is about operating and maintenance. We are going to take a look at load plans, the ODI repository tables, and security. Load plans are an instrument to structure your loads. You can define various step hierarchies, execute them in parallel or serial, and also implement branched execution by using case-when steps. It's also possible to define log level and whether you want to log it all on load plan level. In ODI Studio, you can find the load plans in the Designer tab under Load Plans and Scenarios. I'll open that Load Data Warehouse load plan now. Every load plan has exactly one root steps. You can find all the steps in the tab Steps, and you see here the root step. Under this root step, you can use the step wizard, which is here. And there you can decide whether you want to add a serial, means a sequential step, or you want to have a parallel step execution, or you want to run a scenario, or you want to have a branched execution using a case-when step. The lowest level of the load plans are always the scenarios executed. You can define there whether variables used in this scenario shall be updated and overwritten at runtime or not. By using the parallel or serial step hierarchy, you can define how the scenario steps defined below them are executed. If you change to the exception step, you can define the steps which should be executed in case an exception occurs. Within each step hierarchy, you can assign one specific exception step or a complete exception step group. Here you can use the same features as for the normal steps. Generally, parallel steps might improve the speed for loading stage tables. Serial steps might be the better choice for loading tables having dependencies. Going back to the Steps tab, I want to explain the various symbols of that display. The two pluses means you want to expand all your step structure. The two minuses mean you want to collapse all. With the plus, you can add your steps directly, the serial step, the parallel step, the scenario step, or the case-when step, or you can use the step wizard to add steps to your step hierarchy. The red X, if you have one, is deleting. With the arrows, you can rearrange the sequence of your steps or step hierarchy. Means you move the step one level down, one level up, or you change the order of sequence of your various steps. Obviously, you can define restart behavior for all steps. Let me add one step here. I choose a serial step, and the next I'm choosing a parallel step, and under that serial step and parallel step I add a scenario step. Let's take that one. Finish, and here, just as an example, let's add another one, which is this loop package, for example. Finish. So, what you could do is you can really define restart behavior for all your different steps. Obviously, you can define restart behavior for all steps. For serial steps, you can define restart all children or restart from failure. Restart all children makes sense when the complete step hierarchy must be executed to resolve the error. You can also define restart from failure, then the steps from the failure step on will be re-executed. For parallel steps, you also have the restart all children functionality, but also the restart from failed children. So for a scenario, in fact, you have restart from new session, where the scenario is restarted but within a new session. Or you have restart from failed step, where all the tasks under this failed step are executed. Or the last option, you can restart from failed task, where only this one task and the following ones are re-executed. You see, load plans offer some functionality to structure your loads and are very useful. You can simply export and import complete load plans, including their schedules. Load plans can be scheduled as scenarios alone, so you can manage your daily data warehouse admin tasks in an easy way. They cannot cover very complex dependencies, but for basic needs, basic requirements, they are absolutely okay. Within the next chapter, you'll see something about the ODI repository tables. Sometimes it's important to know where ODI stores information. As ODI stores all objects in the different metadata repositories, and these are saved in database tables, you can track down the information in these various tables. This is just a short overview of the tables, wanting to name at least a few for you. For this, you have to be aware that ODI was formerly owned by a company called Synopsys. This company was French, hence a lot of tables have French abbreviations and start with SMP, which stands for Synopsys. Let's start an OpenSQL developer to take a look. In master repository, you'll have the security, so profiles and users table. So you see here, profiles table with all the different profiles. And here the user tables. As of now, we only have exactly this one user. But also all the topology stuff. So you'll see the SNP-L schema, which is the table containing all the logical schemas, which I have defined in my ODI repository. And you also have the P schema, and the P schema is the table containing all physical tables, physical schemas defined in my repository. In the work repositories, on the other hand, you'll find all development objects, such as projects, important knowledge modules, sequences, packages, interfaces, procedures, and so on. Interfaces, for example, are stored in the SMP POP table. You see here. You see, I just have 3 interfaces defined in my repository. The packages are stored in the SMP package table. I have 2 so far. And then a new object, the load plans you just heard about in the previous chapter, is stored in the SMP load plan table. Where is it? There it is. I just have defined one load plan. Additional information about the load plans is stored in this LP tables. So you see, it's pretty easy to find out a lot of things. For example, the lookups, of course, they are here with the values and so on and so forth. So be aware that ODI stores all information in the ODI repositories. Therefore, you can dig into the tables to see how all is defined. In fact, you could think that normal update invert statements would be fine to develop everything in ODI. My statement is, I think it's possible, but not supported by Oracle. And one last thing, there are quite a lot of dependencies between the various tables and even the repositories themselves. So, for analysis of the ODI development objects using the repository tables, this is very useful. But really doing everything regarding insert and update, I would really let it go. In the next chapter, we're talking about security. If you develop an ODI, there will be a time when you need restricted security. Basically, you have 2 options. You can store all security relevant information, for example, profiles and users, in the ODI master repository, or you can externalize security using the WebLogic server. As ODI is part of the Fusion middleware, this is without any problem possible. ODI generally differentiates between 2 different security options: the inclusion and the exclusion method. What this means is you must either grant privileges for each specific object, exclusion method, or you grant them in a generic way, inclusion method. A privilege in ODI, for example, is create new interface. So everything regarding security is happening in this security tab. So we change to the security tab, and here you can fill all security relevant configurations into the system. In ODI Studio, you can find all security relevant configurations in the security tab. Within that tab, you have 3 accordions: profiles, users, and objects. Within the Profiles tab, the profiles are differentiated in normal and generic profiles. NG profiles are the normal profiles. They are non-generic, and all others are generic profiles. A generic profile has only privileges on actions and can execute this action on all objects available. A normal profile must have the privileges explicitly assigned to each object, so that it should have the privilege to execute this specific action on this exact object. Out-of-the-box profiles are, just to name a few, designer, metadata admin, simple connect, operator, topology admin, and security admin. These profiles are assigned to users to make life easier. Users are the users logging into ODI Studio. Profiles are assigned to users, but also specific privileges can be granted to a user. The objects are the fine granular privileges on actions which can be executed in ODI Studio. For example, export-import or execute interface, and so on. Let's create a user and assign it to one profile. So I'm clicking here, new user, I name it ODI Designer. I click on enter a password and I give the same password. Click on OK, and then I can save it. I just created a simple user here. What I want to do now is I want that this ODI designer gets the profile designer assigned. So what I do is I drag the designer and drop it on top of the ODI designer user. Clicking here on yes, this grants the profile designer to the user ODI designer. And if you double click on the ODI designer now, you see nothing, but you see it here in the profiles that this specific profile is assigned. Starting from version 11, there is a new feature called password policy. You can click here, select password policy, and if you want, you can harden your passwords or add multiple rules. For example, you can say, I want that the text does not contain, for example, a backslash. And then I can add this rule. So this is all about security. In the next section, you'll learn about scripting ODI, data lineage and impact analysis, and some nice features available in the ODI Studio. In section 8, it's all about additional supporting functions. We're going to take a look at how to automate ODI object creation using Groovy. We talk about impact and data lineaging. We'll have some insight into ODI Studio enhancements like shortcuts, syntax highlighting, and so on. If you have to develop thousands of interfaces or other ODI objects with similar transformations in it, there will be a point in time where you think about automated creation of those objects, the best in a parameterized way. ODI offers various ways to do so. If you're familiar with Java, you can use the Java SDK API coming along with ODI. It's a quite comprehensive and complete set of classes and methods to work on them. This is also a known way to integrate other applications with ODI, for example portals, Enterprise Business Suite or SAP or whatever. Nevertheless, for those of you not as familiar with Java, there's another way starting from ODI 11.116. Groovy. It not only sounds better, but also is a more scripting-related way to automate things in ODI. You have a Groovy editor integrated in ODI Studio, which you can always reach by clicking on Tools, Groovy, and selecting whatever you want from the Groovy menu. New script, open script, save script, and so on. I just created one script here. You'll have to at least get a little bit familiar with the Java SDK, as Groovy uses exactly the same classes and all that. So before starting with Groovy, you should have an intensive read on the SDK documentation. The SDK documentation comes along with the normal ODI documentation. So as you can see here, you have to import all classes necessary to work with the various objects in ODI. For example, the class oracle.odi.interfaces.interactive.support.interactive interface helper with actions. is the helper class to create an interface. What my Groovy script should do is, it should create an interface based upon a source in the target table. It should use a knowledge module depending on the data warehouse layer I want the data to be loaded into. And it should have some special columns filled with specific expressions in the target mappings. For this, I defined multiple tables containing the necessary information needed in the interface. So I have one table holding the source target table, which is the ODI control table here. As you can see, very easy. And it also contains the data models and knowledge module here, as you can see. So the next table is holding the knowledge modules, which are defined per data warehouse layer. And this one here is holding the special columns I want to have added in my various mappings. So that's it so far. And what the Groovy script is doing is, after all the classes are imported, it really connects to my database. You see it here. And then it loads everything from the ODI control table. It loads all the columns from the ODI table. It loads the knowledge module definition here from the knowledge module table, and so on and so forth. And then afterwards, some actions are happening. So you see, it's really a scripting language. If you have done some scripting, you will understand it. So that's fine. Syntax and all is not too tricky. As mentioned, if you're able to script, you're able to use Groovy. Just one tip for the Groovy developing. I would recommend to do it in an external editor and with some syntax highlighting in Groovy, and then just copy it over to the ODI Groovy editor. This ODI Groovy editor sometimes really is slow. As you can see, a script makes life a little easier. It's even possible to access certain menus from within the ODI Studio, but what's in fact happening in the background with a script is that you can really generate things in an automated way. So you can really create a whole ODI development from some definition tables. If you have all that together, you can do that with one click. In the next chapter, we talk about impact and data lineaging. Very important in ETL tools is the feature to do data lineage and impact analysis. Data lineage means that you can always follow the track your data takes through the different data servers. You can see how data is transformed by which interface or procedure and so on. In fact, you can do that everywhere in ODI. Data lineage is deeply integrated. When you go to the knowledge module, for example, and you collapse it down to display the options, you'll also see a uses. You see it here. Within this uses, you can see which interfaces are exactly using this knowledge module. Same for the interfaces, packages, and procedures. If you go to an interface, you always have a uses and you have a used by. And a new feature in 11.1.1.6, also shortcuts. So what you see here is you have an interface which is used in a package. If this is not enough for you, there's a web application deployed into WebLogic server. To start that, you have to really kick off these different steps which are listed on my desktop. You can find them also in the Start Programs menu. And WebLogic, there's the admin server console, and then you have the managed server also, which is responsible for the web application. So if you want to take a look at that all, you have to start that, and after all is started, you can access a web application using the browser and see which path your data is taking. Also, impact analysis is possible from here because you can see which objects are affected by the changes you plan to implement. The web application is really useful, but by far not as powerful as ODI Studio, which I demonstrated before. There are certain limitations, but at least drill down and up are possible. So you see here some of the screenshots. Data lineage, what you can do is you can select a model, select a submodel and a certain data store, and then click on view, and then you'll have something like this, a really data lineage. You can see that your data is going from here over to over there, through that one interface, down, up to the various other interfaces. So this is the way you can really track down which flow your data is taking. Every of these objects is drillable, clickable, and that means all these things you can click, and then hyperlinks are used. You can drill down to a very detailed level. You see, ODI Studio offers a lot of transparent information for you. Learn to use it and you'll love it. In the next chapter, we talk about ODI Studio enhancements, shortcuts, syntax highlighting, and so on. This last chapter covers some new features which came with the latest ODI 11G release. Let's start with shortcuts. Shortcuts provide short access to commonly used objects. For example, they can serve to access interface templates. Objects which can be referenced are data stores, interfaces, packages, and procedures. Shortcuts can also be executed in load plans and be used in smart export imports. So how do we create a shortcut in ODI then? So in ODI, simply click on an object, right-click, select copy, and then you can paste it wherever you want it. Right-click and select paste as shortcut. And you see, you have exactly this shortcut here in this other project folder. So there are some limitations. Shortcuts of data models must be copied to another model or submodel, as the source comes from. For interfaces, procedures, and packages, they must be copied to another folder in the same project, as you have seen just in my demonstration. You can use the following actions with those shortcuts. Paste as shortcut, duplicate selection as shortcut, materialize shortcut, which will cause that an exact copy of this object will be created, a so-called clone. All shortcuts can be edited with the new Shortcut Manager. So how would it make sense to use them though? You could, for example, create a folder within your project called templates, as I did here, and from there you can copy the various objects to the real folders of your projects. This makes life a little easier because what you have is you have a structure in your interface. You have standardized or you have predefined knowledge modules in there. You have perhaps a CKM, a check knowledge module defined in there. All this can be done automatically. It can be predefined for your developers so that they can really use the shortcuts and use a standardized look of your interfaces. The same is valid here for the template package, for example. You can use something like a start procedure, end procedure, email procedure, which is the standard for all packages you want to create, and then you can use it everywhere throughout your project. One of the next good features is autocompletion. So what I do is, I'm creating a new model and I want to select the technology now. So I can type it and he's autocompleting it for me here, as you can see. And the same you can do pretty much everywhere in ODI. Next thing which is possible, I can do something like keyboard shortcuts. So Control Z, copy, Control V for paste, Control Z for undo, Control Y for redo. All this is running in ODI Studio. So ODI Studio is one of the very rare Java user interfaces where this actually is running. So this is it for the ODI Essentials screencast. Thanks a lot for listening to it. It's really just a selection of important topics and it delivers a first insight into ODI. No way it can cover all areas of ODI. For this, normally at least a week of intensive training is necessary. So, should there be questions, please contact the publisher or me directly. Have a good time and so long.